Hello dear students of the 6th elementary grade, and welcome to a new episode of our program. This is our weekly episode of science, and on this episode we'll be reviewing the first lesson of Unit 1, Levers, and we'll also be starting the second lesson, Levers Law, with our teacher of science, Mr. Nader Nassim. Let me first welcome him. Hello, Mr. Nader, and welcome to the program.
Hello, thank you. Hello.
So, Mr. Nader, we have a surprise for you. We've got some of the top students with their pictures, and let us now show these pictures and tell you about their names and grades. Okay, Mr. Nader, let us start. We've got طبعا بنقول congratulations لكل الناجحين والمتفوقين، وهنعرض بعض الصور لبعض الطلاب المتفوقين. يعني طبعا حاجة جميلة جدا. نتمنى ان احنا نشوفهم دايما ناجحين ومتفوقين، ونتمنى غيرهم باذن الله ان هم يعني يبقوا زيهم ويتفوقوا عشان دايما نكرمهم. Okay, Mr. Nader, let us start by showing the pictures of those top students. We've got first of all رودينا.
Okay, رودينا
يحيى محمد. رودينا يحيى محمد ورودينا هنشوفها على الشاشة.
Okay, but please, Mr. Yasser, let me introduce my congratulations to all those students because they have excellent marks, especially in science. Okay, so the first pupil, as we see now,
رودينا يحيى محمد 100%. ما شاء الله، برافو يا رودينا.
Another student.
مرام أحمد فاروق برضو حاصلة على الدرجة النهائية 100%. برافو يا مرام.
Another one.
زياد محمد إبراهيم و 100%. برافو يا زياد.
Okay, congratulations to all of them.
وإياد أحمد محمد 99%. برافو يا إياد.
Congratulations also to إياد.
زياد وليد 99%. برافو يا زياد. ويوسف باسم 99%. برافو يا يوسف. واخر صورة معانا سارة هشام ابو الوفا 98%. برافو يا سارة. يعني طبعا حاجة جميلة جدا، الدرجات بتاعتكم جميلة جدا، عايزينكم دايما كده تبقوا متفوقين. وطبعا دي مجرد يعني بعض الصور للطلاب المتفوقين، في غيرهم كتير جدا، لكن ده اللي اتاح لنا من خلال هذه الحلقة. وزي ما قلت لكم ممكن من خلال جروب البرنامج اللي عايز يشترك معانا في عرض صوره على الشاشة يبعت لنا على جروب برنامجنا على الفيسبوك، مدرسة على الهواء ابتدائي واعدادي. ده اسم الجروب، مدرسة على الهواء ابتدائي واعدادي، ابتدائي من غير همزة واعدادي بهمزة من تحت. وان شاء الله هنعرض لكم الاسبوع القادم صور مش بس في الساينس، مش بس خاصة بالساينس، ولكن خاصة بدرجاتكم كلها في جميع المواد. يا رب تكونوا مبسوطين، ونبدأ حلقتنا مع مستر نادر Unit 1. Mr. Nader, let us first begin by reviewing the most important things we had on our previous episode, levers.
Okay, Mr. Yasser, we have studied that lever. As we know, lever, the definition of lever is a rigid bar, straight or curved, that rotates around a fixed point called fulcrum, and affected by two forces, which are the effort force and the resistance force. Again, the definition of lever is very important definition. Lever again is a rigid bar, ساق متينة, straight or curved, that rotates around a fixed point called fulcrum and is affected by an effort force and a resistance force. An effort force and a resistance force. Okay, so that's the definition of the lever, and it's very important definition. Also, we have decided that levers are classified into three types, or three main types, which are first class lever, second class lever, and at last third class lever. We have studied those three types of levers: first class lever, second class lever, and third class lever. And also we have learned how to classify each lever we have studied. Okay, like that. Any lever contains or consists of three main points. Any lever consists of three main points, which are fulcrum, that has a symbol O, effort force, that has a symbol F, and resistance, that has a symbol R. Again, a lever, she has 3 points: O, R, F. O again, O fulcrum, R resistance, F which is the effort force. How can we classify each one of this lever, we can classify the lever simply by imagining or by drawing each lever. لازم أرسم أو أتخيل lever. If the fulcrum in the middle between the effort force and the resistance, it will be the first class lever. If the resistance between the effort force and fulcrum, it will be the second class lever. If at last the effort force, which has symbol F, between the fulcrum and the resistance, it will be the third class lever. So we have the secret word. Can you remind me, Mr. Yasser? Secret word, which one?
Yeah.
ORF.
ORF. we say ORF. يعني ايه ORF؟ عايزين نفسرها شوية عشان برضو اللي ما تابعوناش قبل كده.
Okay. ORF means ORF. If O in the middle, it will be the first class lever. If R in the middle, it will be second class lever. If F in the middle, it will be third class lever.
يعني دي طريقة مبسطة بنقدمها لكم عشان تقدروا تحددوا الليفر ده يا ترى بينتمي لأي كلاس، هل هو first class ولا second class ولا third class، ومستر نادر برضو هيوضحها لكم قدامكم على الشاشة دلوقتي.
Okay, Mr. Yes. Okay, if O in the middle like this, O in the middle between R and F, it will be first class lever. It will be first class lever. If O in the middle, it will be first class lever. Okay, again another drawing, please. If O in the middle like this, R, F, it will be first class lever. So I can write here first class lever. So what about if R in the middle? If R in the middle, like we have studied, if R like this, F and O, it will be second class lever. Okay, it will be second class lever. So what about if F in the middle, F, the last one, F in the middle between O and R, it will be third class lever. Third class lever.
Okay, so عشان كده بنقول ORF.
ORF. يعني لو أخذنا كده كل كلمة في الميدل O R F. ORF is a secret word that determine the type of the lever.
But there is another important question here, Mr. Nader. How can we determine if O or R or F are in the middle?
Okay. We can imagine or draw simply the lever. يعني مش عايز drawing complicated قوي. Simply drawing, and we can determine F at your hand. F is the force that you exert. F is the force that you exert. So F is at your hand. O is the middle, or O is the point of movement. So we can see that fulcrum, O is the point of movement. Okay. So okay.
Yeah.
Okay. So
نقولها بالعربي.
نقولها بالعربي. O هي مكان الحركة. لكن F هي مكان القوة اللي أنا بستخدمها at my hand عندي إيديا أنا شخصيا. But R أو resistance هي المكان اللي أنا عايز أعمله أو الشيء اللي عايز أعمله. For example, if I carry something or raise something heavy by the crowbar, so the heavy something is that R. So I can say that F at your hand, F عند إيدك أنت شخصيا. O at the point of the movement or the point of the rotation, but R is at the point of the movement of something or carrying something or the something that you can do, something that you can crack like nutcrackers, like a startled bundle, something like you cut like the scissor or mouse and so on. Okay?
Okay, can we have examples?
We have many examples and practice here, Mr. Yasser.
Yeah.
Okay, so any lever consists of three main points as we have said, that are fulcrum, which has a symbol O, effort force has a symbol F, and resistance has a symbol R. Okay, so resistance, force, effort force, fulcrum, they are the 3 points of any lever. Okay, so now resistance force has a very important definition, which is the force that resulted from the weight of the body that you want to move or want to carry or want to raise or want to cut. Anything that you want to do, it is the resistance force. أي شيء عايز أعمله، الشيء اللي بحطه عند الليفر أو الروافع أو الرفعة اللي بستخدمها هو اللي هسميه resistance force. Okay? So what's about the effort force? Effort force, as we know, is the force that is exerted by a person to equilibrate the resistance. Again, it is the force that is exerted by the person to equilibrate the resistance. هي الفورس اللي أنا ببذلها عشان أعمل توازن مع المقاومة. Okay, so what's about the fulcrum? Fulcrum is the fixed point where the bar or the lever rotates on. It's the fixed point where the bar or the lever rotates on. So now,
and it starts with F, but its symbol is O.
Okay, we have a very important note, as you said, Mr. Yasser. Fulcrum has the symbol O, not F. Okay, we have many examples of lever. We can see them in our daily life or at our home or at school or anywhere, like the seesaw, the crowbar, the scissors, pliers, nutcracker, stapler, ice or sweet holder, wheelbarrow, and so on. Okay, so now types of lever are classified according to the midpoint or the middle point, as we have said, like that. First class lever, they are the levers that have the fixed point fulcrum O between the effort force F and the resistance force R. Again, first class lever, they are the levers that have the fixed point fulcrum O between the effort force F and the resistance force R. So that's the first class lever. So what about the second class lever? As we have known now, second class lever, they are the levers which have the resistance force between effort force and fulcrum. They have R in the middle between O and F. So we can see that second class lever, they are the levers that have the resistance force between effort force and the fulcrum. Examples of the first class lever, as we have studied: seesaw, crowbar, suction pump, pedal المقداف, nail clipper قصافة أو قلامة الأظافر, as we can say in Arabic, pliers الزردية أو الكماشة, scissors, balance, pincers, and claw hammer. Have a definition for second class lever now. They are the levers that have the resistance force R between the effort force and the fulcrum. They are the levers that have the resistance force between effort force and the fulcrum. Examples of second class lever: wheelbarrow, nutcracker, stapler, and at last soda water opener or bottle opener, as we can say. So what's about the third class lever? As we know, third class lever, they are the levers that have the effort force F between the resistance force R and the fulcrum. So now we have examples of third class lever: tweezers, manual broom, hockey pat, fishing tool, ice holder, sweet holder, and at last coal holder. So now let's have a practice to classify some levers into their types. You are ready, Mr. Yasser, now?
Yeah.
Okay, now I will present or offer to you, to our my students and you especially, some pictures for the lever, and we can classify them into their type.
Yeah.
Okay, let's start with the hockey pad. The hockey pad. Here I have F in the middle. F here in the middle between O and R.
So, it's
it will be no F O R F.
Yeah, O R F.
Yeah.
So F is in the middle. So this is the second.
No, the third F. F in the middle. O R F.
O R. Yeah, O R F. Yeah. Sorry.
Okay.
Yeah.
So if F in the middle, as we have said, it will be the third class lever. If O in the middle, it will be first class lever. If R in the middle, it will be second class lever. Again, O in the middle, it will be first class lever. R in the middle, it will be second class lever. And at last, if F in the middle, it will be third class lever. Okay?
Yeah.
Sorry, Mr. Yasser, you have lost this picture.
Yeah.
Another one. Try again.
Lost the mark.
Okay, lost the mark. Pincers. We have a very important and clear picture for the pincers.
Yeah.
Okay? Here I have O in the middle. O in the middle.
So
yeah,
it's
it will
for
be
sure first class.
That's excellent. You have a mark now, Mr. Yasser.
Yeah,
okay. So here pincers have O in the middle between R and F. So we can say that pincers are classified as a first class lever. So if I have to give reason here, Mr. Yasser, okay, give reason. Pincers are classified as a first class lever. Why?
Because
or give
the
reason?
fulcrum,
Because the fulcrum,
lies between the
resistance
force and the
effort
force.
So the answer, simply as you said, Mr. Yasser, is that because the fulcrum O is between or lies between يقع بين أو يوجد بين the effort force and the resistance force. It is a simple answer. Okay. Another one. Okay, the wheelbarrow عربة الحديقة. Here I have R in the middle, R at the something that I want to carry, O at the wheel of the wheelbarrow, F at the hand of this man, this strong man who pushes this wheelbarrow.
So it's a second
class lever. So if I have another give reason here, give reason wheelbarrow is a second class lever, so I can say because
again
wheelbarrow,
because
the
resistance lies between the
O
fulcrum and the
effort force. Very good, excellent, Mr. Yasser. You have another mark. Okay. Okay. So what about the balance? The balance is a very important lever that we can see it in our everyday life at supermarkets, at shops, and at hypers. Yeah, in Mizan. The balance is a first class lever. Why? Because here I have O, or the fulcrum between R and F. O, the fulcrum between the resistance and effort force. Okay. Another example. The stapler, the besa, staplers is from what, Mr. Yasser? Here I have R in the middle.
Second class lever.
Second class lever. Why? Or give reason?
Again, because R, or the resistance, lies between the fulcrum and the effort force.
Okay,
right?
Excellent. Sure, excellent, Mr. Yasser. Right, because stapler has the resistance force between effort force and the fulcrum, so it will be classified as the second class lever. Again, stapler is a second class lever. Another one.
Am I a good student?
Yeah, very good, excellent, Mr. Yasser. Okay, the pliers, الزردية, as we can say in Arabic, have the fulcrum, as I can see in the picture, between effort force and the resistance. So we can classify the plier, as we will see now, the plier from the first class lever. Why we can say the plier is from first class lever, or why we can say, or we consider the pliers are from the second class lever, as we have said more and more, because the plier contains, or the pliers have fulcrum, which is symbolized by the letter O between the resistance force and effort force. Another picture. The cold tongues, you can see, Mr. Yasser, the cold tongues here. I have F between R and O. I have F between R and O.
So this is for sure the third class
lever for sure. Third class lever. Why? Or give reason? Because we have
here the effort force lies between the fulcrum and the resistance force.
Surely you are right, Mr. Yasser. Cold tongue or cold holder, or any holder like the sugar holder, sweet holder, ice holder. Okay. Any holder is considered from the third class lever, or the third type of lever, because they contain the effort force between the fulcrum and the resistance. Okay, so now I have a picture, or another picture, for the crowbar, which is the lever that you will use to move the huge rock on the road. Okay, look here, Mr. Yasser. I have the O, the fulcrum between F and R.
So this is for sure the first
class lever. So we can say the crowbar is a first class lever because it contains fulcrum between F and R. Another picture, the manual broom. The manual broom is a very daily life lever. We use it at our home. Manual broom. Okay, here I have F between O and R. I have effort force between resistance and fulcrum. So it will be what, Mr. Yasser? It will be surely the third class lever, because it contains effort force between resistance force and the fulcrum. Another one, or another lever, very important lever, that is the bottle opener, or soda water opener. It will be what, Mr. Yasser, here? I think it will be the second class lever. Why? Or give reason? Because it contains the resistance between fulcrum and effort force. It contains, or consists of, resistance between fulcrum and effort force.
Can we receive our first caller?
Okay, Mr. Yasser.
First call, min Yusuf, min Iskandariya. Hello, Yusuf. How are you? Yusuf? Can you hear me, Yusuf?
Yes, I'm fine, thank you.
How are you, Yusuf? Yusuf, could you please raise your voice?
Yes.
Okay, Yusuf.
I want to be asked.
Sorry?
I want to be asked.
He wants to be asked.
Yeah, he wants to be asked. So, all right, I'm going to ask you a very easy questions. Okay?
Okay.
Why are levers so important in our daily life? What is the importance of a lever?
Because they are used in increasing force, increasing distance, increasing speed, moving force from one place to another, picking up the very small object affecting tangent.
Excellent answer, Yusuf.
Yeah.
Excellent answer.
Great.
Yusuf said that lever increase force, increase speed, increase distance. Lever also moves force from place to place. Lever also are used to avoid danger or when we want accuracy in performance.
Yeah.
So that's a very.
Will you ask him another question,
Okay,
Mr.
I will give him a practice now.
Yeah.
He will have a picture, Yusuf. Okay, you will see a picture now of the fishing tool. Okay, Yusuf, you will see a picture of the fishing tool, and you can classify the type of this lever, the fishing tool, Yusuf. Okay.
Okay.
Okay. Now you will have a picture. هنشوفها مع بعض حالا Yusuf. The picture or the image of the fishing tool. I have effort force between resistance and fulcrum, as we can see now. Okay. Okay, Yusuf.
Okay.
The fishing tool, you know. Okay. Here, Yusuf, your picture of the fishing tool or the fishing hook.
Fishing tool, third class lever.
Why Yusuf, fishing tool is considered from the third class lever?
Because the force between resistance and fulcrum.
Because the effort force is between or lies between the fulcrum and the resistance, so we can classify fishing tool as the third class lever. Okay, Yusuf?
Okay.
Okay, so we can classify fishing tool as a third class lever.
Okay, thank you, Yusuf. Thank you very much. Okay, let us carry on.
Okay, let's carry on. We have another picture of the nut cracker cassette fondo. If you want to crack nuts, Mr. Yasser, what will you use? Your
Our teeth.
No, it's very dangerous, as you said before. It's very dangerous for your teeth. Okay, we can use simply the nut cracker. Nut cracker can crack the nuts simply and easily without paining your teeth or without causing pain for your teeth. Okay.
Yeah.
Okay. Nutcracker, as we see now, have resistance at the point or at the place of the nut between fulcrum and effort force. So we can say nutcracker is from what, Mr. Yasser? From what type?
If R is in the middle, so it's a second class.
It is second class lever. So again, R in the middle, so it will be the second class lever. Okay. I think I have this last picture of this practice. Scissors, I have here in scissors, O between R and F, so it will be what? Scissors?
Yeah, first class lever.
First class. So we can classify each lever simply, as we have said, by imagining or by determining, the three main points, which are fulcrum that has a symbol O, F or effort force that has a symbol F, and at last resistance which has a symbol R. So now, when does the lever save effort? This is our lesson today, which is the lever law. ده درس النهارده اللي بنسميه lever law.
Okay, but before we get started with this lesson, let us have this call from Dalia من أسوان. أهلا بك يا داليا.
كويس الحمد لله.
How are you?
I'm fine, thank you.
شفتي الحلقة من أولها؟
لا ابتدي دلوقتي.
لسه من دلوقتي؟ طيب, you want to be asked or you have a question?
Yes, I want to be asked.
You want to be asked. Okay, Mr. Nader will ask you a question now.
Okay, Dalia, you have studied levers lesson only or levers law?
What?
You have studied how many lessons up till now?
The first lesson.
First lesson only, levers, okay?
Of levers.
Okay, so Dalia, can you tell me what's meant by levers? What's meant by levers?
It's a raised bar.
Yeah, rigid bar. Straight or curved? Rigid bar, straight or curved?
Rotates around a fixed point.
Rotates around a fixed point. Yeah, Dalia, very good.
Called fulcrum, and it is affected by an effort force and resistance force.
Very good, excellent, Dalia. So Dalia, can you tell me what type of lever is the scissors? What type of lever is the scissors?
The first class lever.
First, the last question for you, Dalia. What type of lever is the seesaw? Seesaw, المرجحة. Seesaw.
First class lever.
First class lever.
Okay, Dalia, I want to ask you a question. Okay.
Okay.
Do you crack nuts by using your teeth or by using a nut cracker?
Nut cracker.
Nut cracker? Are you sure?
Yes.
Okay, so why is a nut cracker considered a second class lever?
Because the distance is between effort force and fulcrum.
Okay. Bravo, Dalia.
Excellent, Dalia.
Thank you very much, Dalia min Aswan. Okay, let us carry on and let us now start the second
lesson. Yeah.
And we'll be dealing with the law itself.
Okay, the lever's law, as we said, this lesson deals with how mechanical benefit does the lever save. ازاي lever بتوفر مجهود. And in simple words, we can say that which lever is the best type, the first type, second type, or the third type. We will find now. Okay, so again, we have a question here to answer. To answer this question, we must study this lesson about lever's law. Lever's law says that effort force by effort force arm equal resistance by resistance arm. Again, this is a very easy and simple law which says that effort force by effort force arm equal resistance by resistance arm. About this law, we have problems, and to answer this problem simply and correctly, we must at first write the law. So now, to make less effort or small effort force, يعني عشان أبذل مجهود أقل, to make less effort or to exert less effort, so the effort force R must be longer than the resistance R. Again, to make less effort or small effort force, the effort force R must be longer than the resistance R. So we have an only condition here for the lever to save effort. عندي شرط واحد بس للlever عشان توفر مجهود. What is this condition? ايه هو الشرط دوت؟ This condition is that the effort force arm must be longer than or larger than or taller than the resistance arm. Again, the effort force arm, as I said, must be longer or taller than or larger than the resistance arm. Again, must be longer than the resistance arm. So now, let's have a practice. And now, what type of lever is the best type to use? Mr. Yasser?
Or the most used?
No, I mean here, what type of lever that saves more effort?
Yeah.
Not for avoid danger and so on. That type of lever that saves effort. Okay? So now I will draw simply each type of lever and determine the effort force arm and the resistance arm. Okay? So now here the first class lever, as we have studied, contains fulcrum between effort force and the resistance. Okay? Here the first class lever. I have here O, F like that, and R. Here I have second class lever, R between F and O. And at last, third class lever, I have F between O and R. So here I have two arms in each lever, which are effort force arm and resistance arm. Effort force arm and resistance arm. Effort force arm, as I said before, or as I will say now, it will be the distance between the effort and the fulcrum. In any lever, effort force arm, it will be the distance between the effort force and the fulcrum. Okay, so I can draw it here with the green color. Okay?
Yeah, okay.
Here I have the effort force between the effort force and the fulcrum. Here I have effort force arm. Okay? Here I have the longest effort force arm I have ever seen in the second class lever. Again with the green color. Okay? I have the effort force arm here between the effort force and the fulcrum. Okay? So what about the resistance force arm or the resistance arm? I will draw it with the red color. So it will be here, the resistance arm, which is the distance between resistance and fulcrum. It will be here the shortest length. It will be here the longest length. Okay, Mr. Yasser?
Yeah.
Okay. Look here about the arms. The arm is here, the resistance arm here, the resistance arm here, the resistance arm here. I said I have one condition only for the lever to save effort. Is that effort force arm must be longer than the resistance arm. يعني عايز يكون الeffort force arm اللي هو باللون الأخضر زي ما رسمنا هنا يكون أطول من resistance force arm. So again, which lever we have drawn has the effort force arm longer than the resistance force arm. نشوف تاني مع بعض الصورة please. Okay, بص يا مستر ياسر معايا. Concentrate please. Which lever, first or second or third, have the green line which is the effort force arm longer than the resistance arm? You said the second,
Second,
okay?
yeah.
It is the second. Here I have the green line longer than the red line.
Yeah.
But here I have them equal.
Yeah.
In the third type, I have the resistance arm longer than the effort force arm. Okay? So here I have the second class lever, which is the best type of lever. Best type of lever, why? Because it has or it contains effort force arm longer than or larger than the resistance arm. Again, I have only one condition. في شرط واحد بس for the lever to have a mechanical benefit or to save effort. Is that effort force arm longer than the resistance arm. Okay, so which type is the best type of lever? So surely it will be the second class lever. Second class lever saves more effort, more than the first class lever and third class lever, because it contains or it has more longer effort force arm than the resistance arm.
So we're talking here about levers.
No,
levers,
not levers, Mr. Yasser.
Okay, so do you know what does one lever say to another lever?
I leave you.
Yeah,
you said
I
it,
love you.
Yeah. You told it me before. Okay,
Yeah.
I leave you, not I love you. Okay, so Mr. Yasser is joking as usual and said one lever tells another lever that I leave you, not love you. Okay, Mr. Yasser, you're usually joking. Okay, so again, I have one condition only for the lever, not the lever, the levers to save effort, is that effort force arm must be longer than the resistance arm. Again and again, it's a very important condition, and we have only this condition, no more condition, is that levers save effort only if effort force arm is longer than the resistance arm. And this condition is available as the second type of lever only, Again, the condition for the lever to save effort is that effort force arm is longer than the resistance arm. Okay, so now I have a problem. Okay, Mr. Yasser, you are ready to solve problem with me? I said to solve a problem, we must write only
I am
the law.
very bad at solving problems.
Yeah. Why, Mr.
So
Yasser?
teach me now.
Okay, I will teach you and I will teach with you.
Yeah.
Okay, so to answer the problem of lever, first step is that you must write the law. Okay, you must write the law in abbreviation, not the huge words. Okay, I said that effort force by effort force arm equal resistance by resistance arm. So I can write that by this F, like the effort force, by effort force arm, F dot arm. Okay, so this is abbreviation of effort force arm equal resistance by resistance arm. Okay, and now I can read the problem and classify the numbers or the values to its type. So the problem says that if a boy sits on a seesaw, its weight is 250 Newton. So we can consider the weight of the boy is the effort force. So I can write here 250 Newton under the effort force. I can write here 250 Newton under the effort force. The problem says again, at a distance about 3 meters from the fulcrum, 3 meters, so it will be the distance or the effort force arm. So I can write 3 meters under the effort force arm. Again, I wrote 3 meters under the effort force arm. From the fulcrum, and a girl sits on the other side, her weight is 150 Newton. So I can consider the weight of the girl is the resistance. So I can write here 150 Newton under the resistance. Here I have a seesaw. In seesaw, Mr. Yasser, we have a very important note. We can consider the boy or the someone who sits on the seesaw on the right, for example, F, and the other will be the R. And you can consider the one who sits on the right, R, and the other will be F. It's alternative, okay? So I wrote here 150 under the resistance, and at last he wants me to calculate the distance between the boy and the girl, or the girl and the fulcrum, to have a balance. هنا اعتبرت ان الولد هو الeffort، والديستانس اللي عنده هو هي نعتبرها الeffort force arm، الجيرل هي اللي اعتبرها resistance. الديستانس اللي عشان يحصل بينها وبين الولد balance او بين البوي balance هحسبها ازاي؟ I have here 4 values in each problem of levers. So I have here 3 values only and the fourth value is absent or is required. القيمة الرابعة هي المطلوبة. I can write it now R dot arm resistance and I can answer it R arm or resistance arm equal. Here, Mr. Yasser, I have 2 sides. Look here, 250 by 3, 150 by resistance arm. Which one of the 2 sides, the left side or the right side, is completed with numbers? The left side,
the first one, yeah,
the first one or the left side. So I put it at the top of the fraction, 250 by 3, and at the bottom I put the other side, 100. Yeah.
The nominator.
Yeah, nominator and denominator, or we can call this in mathematics cross multiplication. Multiplication أو حاصل ضرب الطرفين فلسطين, as we can say in Arabic.
You also teach math?
Yeah, no. I know math only for this problem.
Yeah,
okay. Okay. So again, we can answer the problems of levers easily by number 1. You must write the law. Write the law correctly in abbreviation letters. Okay. And after that, you must classify the values of the problem under its name. And at last you will find one of these values will be required. So here, resistance force arm or resistance arm will be that equal 250 by 3 divide 150. I can divide by 3 equal 1 by 3 equal 50 by 50 equal 1 by 50 equal 5. So it will be 5 over 1. It will be 5 what? Here is the arm as the arm in the example. The arm in the example is 3 meter. So 5 here equal 5 meter. 5 here equal 5 meter. Okay? So the answer of the problems of lever is very easily and simply. At first, I advise you, you must write the law. لازم أكتب القانون in a correct way and in abbreviated form. بصيغة مختصرة وبشكل صحيح. The law says again, effort force by effort force arm equal resistance by resistance arm. Okay, Mr. Yasser?
Yeah.
Have another problem?
Yeah.
Okay. Have another problem or another example to practice about the lever's law. Okay? The lever's law says that again, effort force by effort force arm equal resistance by resistance arm. Another problem says that a long uniform metallic bar is hanged from its mid. I can imagine this problem. Okay? A long metallic bar is hanged from its middle like this. Okay?
Mr. Nader, explain the word uniform here, because I'm sure it's not what they wear at school.
Uniform here, it has the same thickness.
Yeah.
Okay? It has the same weight in all its parts. Uniform يعني يعني متزن أو يعني في كل أجزائه شبه بعض. نفس الشيء is the similar at its parts. Okay? يعني ساق متزنة أو ساق متينة لكن أجزائها كلها زي بعضها. ما فيش جزء فيها more heavier than the other أتقل 200. Okay. لكن يونيفورم مش معناها زي الموحد أو زي المدرسي يعني. Okay.
Okay, let us, we can use the help of Ahmed to answer this problem. Okay. Hello, Ahmed, how are you?
Hello, Master.
How are you?
I'm fine.
Okay, Ahmed, have you been watching us?
Yes.
From the start of the show?
Yes.
Okay, do you understand everything we've explained?
Yeah.
Okay, do you have any questions first?
No.
You want to be asked? Okay, can you solve the problems?
Yeah.
Are you good at that?
What?
Are you good at that?
Yeah.
Because I'm not. Okay, so could you please solve this problem with Mr. Nader? Okay?
Okay.
Let us have this problem. Let us show it on the screen. أعرضها على الشاشة وأحمد يساعدنا في حلها.
Okay, Ahmed, you are ready now?
Yeah.
Okay, at first, Ahmed, you can tell me the lever's law. Lever's law, Ahmed, you remember it?
Lever's law?
Yeah.
What I say about lever law?
Effort force by?
Yeah. Effort force times its arm equal resistance force times its arm.
Okay, so the question says, Ahmed, a long uniform metallic bar is hanged from its midpoint. A force of 40 Newton exerts at 5 centimeter. So here I draw force here of 40 Newton. 40 Newton. exerts at 5 centimeter. So I can draw, or I can write, sorry, 40 Newton under the effort force by 5 centimeter equal the resistance. Here he said that find the weight which must be hanged. Find the weight، عايز اوجد الوزن الذي متعلق الناحية الثانية to make the bar get balanced at 25 centimeter. Again, find the weight which must be hanged at 25 centimeter to make the bar get balanced. So here I have a weight and I don't know its weight, Ahmed, okay?
Yeah.
Okay, but I know that this distance is 25 centimeter. Okay?
Yeah.
So I can write 25 centimeter under what? Resistance or resistance arm?
Resistance R.
Yeah, very good, Ahmed. Surely, excellent. 25 centimeters. So here I want the resistance. So how can I get the resistance, Ahmed?
Make 40 times 5.
Yeah, 40 times 5.
Divide 25.
Very good. By cross multiplication, 4 times 5 divide 25. So we can divide or simplify. Divide 5 equal 5. Divide 5 equal 1. Divide 5 also. Divide 5 equal 8. So it will be 8 what, Ahmed? I have resistance like the force. The force here with the Newton unit.
It will be 8 Newton.
Yeah, so it will be 8 Newton. 8 Newton. Very good, Ahmed. Thank you.
Okay. Bravo, Ahmed. Well done. Thank you very much. Okay. Let us now carry on and have more problems.
Okay, I have more problem. You have more time?
Yeah, we still have time. Yeah,
Okay,
sure.
I have many more problems. Okay, another problem said that the length of the crowbar, the length of the, of the force of a crowbar is 100 centimeter, and the length of the resistance arm is 15 centimeter. If the value of the resistance is equal 400 Newton, calculate the value of the effort force and mention the type of the lever. Here, at first, I must write the law as we have learned. Okay, the law says that effort force by effort force arm, we must write the law. Effort force by effort force arm equal resistance by resistance arm. The first step أول خطوة لازم أكتب القانون. The first step is you must write the law. So it will be that effort force by effort force arm equal resistance by resistance arm. Here he said that the length of the force arm equal 100 centimeters. So I can write effort force arm 100 centimeters. نكتب مع بعض 100 centimeter under the effort force arm. And he says that the length of the resistance arm is 15 centimeter. Is 15 not 50, sorry, centimeter. So I can write under the resistance arm 15 centimeter. And he says that if the value of the resistance equal 400 Newton, calculate the value of the effort force. If the value of the resistance here, I can write 400 Newton under the value of the resistance. So here I want the effort force. I want the effort force and also the type of the lever. Effort force and the type of the lever. Here I want the effort force. So effort force is what? I can write that effort force. Here, Mr. Yasser, which side is completed with numbers? The left side or the right side? I see you point to the right side.
We can see if Ziad knows this.
Okay, Ziad.
Could you show him, could you show us his picture? Because he's the one we showed his picture.
Okay.
Could you get it? Or
his picture now?
Yeah.
His picture now.
Yeah.
What's his name, please?
Ziad Muhammad Ibrahim.
Ziad Muhammad Ibrahim.
Yeah, because he is on the phone with us now.
Okay,
hello Ziad, how are you? Ziad.
Hello?
Okay,
أهلا بك يا
Ziad.
زياد.
Your picture now will be on the screen.
Yeah.
Congratulations, Ziad.
Yes, but my name is Ziad Walid, not Ziad Muhammad Ibrahim.
Okay, Ziad Walid.
زياد وليد. هات زياد زياد الثاني عشان احنا قلنا اثنين زياد.
Ziad Walid. Okay, Ziad Walid.
Okay.
Congratulations, Ziad.
Thank you.
How are you now, Ziad?
I am fine,
طبعا
thank you.
زياد اللي في الصورة هو اللي معانا على التليفون. أهلا بيك يا زياد، مبروك النجاح، مبروك الدرجة الجميلة اللي جبتها.
شكرا.
وإن شاء الله بقى الترم الجاي كده نشوفك برضو من الأوائل.
الترم الجاي فول مارك بقى مستر ياسر يعني.
فول مارك يعني هو
هنعديها
جاب
المرة دي.
90%. نعديها المرة دي.
هنعديها المرة دي يعني. اوكي.
اوكي.
زياد المرة الجاية ان شاء الله فول مارك. اوكي.
إن شاء الله.
اوكي زياد.
Okay زياد, do you have any questions or you want to be asked?
لا, I wanted to be asked.
Okay,
Ziad.
could you please ask him a
Okay.
question?
Ziad, we have a problem of lever. Can you tell me what is the law of the lever?
Yes, effort force by its arm
Yeah,
equal
effort force.
Resistance force by its arm.
Okay, effort force by its arm or effort force by effort force arm equal resistance by resistance force arm. Okay, Ziad? Okay, so I have a problem here, Ziad. Can you answer it with me?
Yes.
Okay, so if the question says that effort force, I don't have effort force, but I have effort force 100 centimeter, resistance 400 Newton, and resistance arm is 15 centimeter. Okay?
Okay.
Okay, Ziad.
We will do 400 by 15.
400 by 15, okay. On
Divide
the numerator,
divide
400 by 15, okay.
Divide
And
100.
at the bottom, denominator, 100. Okay, we can omit 2 zeros like this, or divide or simplify. So
Yes.
the answer will be what, Ziad? 400?
Yes.
No, 4 by 15 equal what, Ziad?
Yes.
4 by 15 equal?
4 by 15.
Equal?
Um,
Equal?
60.
60 what?
60 centimeter.
No.
60 meters.
Effort force like the resistance, Ziad.
Sorry, 60 Newton.
60 Newton, 60 Newton,
60
okay?
Newton.
Okay, Ziad. Okay, now Ziad, so the answer will be 60 Newton, 60 Newton. Okay, so I said more and more the answer, or to answer the problems or the Lever's law, we must know the Lever's law. We must know or we must remember.
Ask him one last question.
One last question. Ziad, can you tell me what's meant by lever? What's meant by lever?
It is a rigid bar, curved or straight.
Yeah.
With
Rigid bar, curved or straight?
curved or straight, and it rotates around a fixed point called the fulcrum,
Yeah, excellent, Ziad.
and is affected by resistance force
And
force
effort
and
force.
effort force.
Okay, Ziad, can you tell me the last question? What is the symbol of the fulcrum? Because the symbol is more difficult.
Symbol is
Symbol of the fulcrum? Is it F?
crowbar.
Yeah, is it F, Ziad, or another letter?
What?
Symbol of the fulcrum. Symbol of the fulcrum.
Sorry, O.
Oh, yeah, O. Why we choose O, Ziad, for the symbol of the fulcrum? Not we don't choose the F, for example. Because what? Because we have another
Effort
letter.
force. We have
effort force has a
force.
symbol F. Okay, Ziad.
Okay.
Another
Yeah.
question, Mr. Yasser?
No, that's enough for Ziad, but
Okay.
I'll ask you a simple question. You've been following us since the start of the show, sir?
Yes.
Okay, you concentrated very much?
Yes.
Okay, so what does one lever say to another lever?
It's not science yet.
I love science.
What does one lever say to another lever? I love you.
What?
Look,
I love you.
the lever says to another
Okay,
lever.
that was a
I
joke
love you.
anyway. That was a
Not
joke.
yet,
Okay,
not yet,
thank you,
okay?
Ziad, Walid. Thank you very much.
Thank you.
Okay, thank you. So let us go on.
Okay, we have said
أنا كنت
more and
بختبر
more.
تركيزه مش أكتر.
Okay, we have said more and more. To answer the problem of lever, we must write the law correctly. The law says that effort force by effort force arm equal resistance by resistance arm. Okay, and also to answer the problem of the lever correctly, we must write the law and answer or classify the values under each other. Okay, Mr. Yasser?
Yeah.
Okay, so we have studied up to now types of lever, the importance of lever, and at last the lever law. We have 3 types of lever, which are first class lever, like the seesaw, like the scissors, and we can say that first class lever is the lever or are the levers that have fixed point, which is called fulcrum, between resistance force and effort force. And second class lever are the lever that have resistance force between effort force and the fulcrum, like the nutcracker, like the soda water opener, like the wheelbarrow, and so on. And at last we have studied the third class lever, which contain the effort force that has a symbol F between resistance force and effort force. And also we have studied many examples of the third class lever, which are the like the fishing tool, like the hockey pad, like the coal holder, ice holder, sweet holder, and so on. So okay, Mr. Yasser, do I have time for another problem?
Yeah, but do it very quickly.
Okay, the problem says that the length of the force arm of a crowbar is 100 centimeter. So at first I must write the law. Write the law quickly because we have no much time. Effort force by effort force arm equal resistance by resistance arm. Okay, here the length of the force arm of the crowbar is 100 centimeters. So I write 100 under the effort force arm. And the length of the resistance arm is 200 centimeters. Okay, length arm of the resistance 200 centimeters. I write 200 under the resistance arm. If the value of the resistance is 400 Newton, value of the resistance is 400 Newton, so I write 400 here under the resistance. Calculate the value of the effort force and mention the type of lever, and it saves if mechanical benefit or not. So here I have effort force is wanted. نرجع مع بعض للو نكتب مع بعض القانون من تاني. Effort force by effort force arm equal resistance by resistance arm. So here I have, or I want the effort force. Effort force equal, as in this law, 400 by 200 divide 100. Again, effort force equal 400 by 200 divide 100. So it will be, I can omit 2 zeros with the 2 zeros, so it will be 800. نكتب مع بعض. The lever's law says that effort force by effort force arm equal resistance by resistance arm. So it will be F by 100 equal 400 by 200. So F equal 400 by 200 divide 100. So the answer at last, 400 by 2 equal 800 Newton. And don't forget to write the unit because it has a mark. Okay.
All right. Okay, Mr. Neder, are we going to have more problems on our next episode, or are we going to move on to another lesson?
I think I have more problems, like 3 or 4 problems, and move to a new lesson next episode. Okay.
Okay. So I'd like to thank you very much, Mr. Neder Nassim, for your great effort. Thank you very much.
Thank you very much.
So that brings us to the end of this episode, dear students of the 6th elementary grade. We've had the first and second lessons of Unit 1, levers and levers law, and also we'll be having more examples on our next episode. ما تنسوش تنضموا كلكم لجروب برنامجنا على الفيسبوك، مدرسة على الهواء ابتدائي واعدادي، ابتدائي من غير همزة، اعدادي بهمزة من تحت. وإعادة هذه الحلقة للي فاتوا أي جزء أو للي ما تابعهاش من البداية هتكون إن شاء الله في الساعة 5 صباح الغد، وإن شاء الله نشوفكم في حلقة جديدة. Until we meet you again, it's goodbye.